Okay, so we have an example here about running an ANOVA test for data on two different groups of data. There's questions like this already on our Blackboard, but I want to pay particular attention to the bottom section here on how to run an independent measures t-test on the same data. So before we do that, we're just going to plug everything we have into our calculator, into our stat list. So I'm going to go to Edit, List. I'm going to clear all three of these out, just to avoid any confusion, having a third list. I'm going to plug my values in one by one. L2. Add it all in there. So now it says using SPSS, not sure what that is, but we're just going to use our TI-84. Run the independent measures single factor ANOVA for this data. So to do that, I'm going to go to my stat menu, over to test. It's the very bottom option, so I'm just going to scroll up. You'll see ANOVA. Now, most of the other tests you run will give you some screen asking you for specific inputs. This just gives you an ANOVA with an open parenthesis. So it just wants to know what lists are we taking the data from. So I'm going to select second one to plug in L1, and then I'm going to put a comma. Second two to plug in L2. Close my parentheses. I'm going to hit enter. It's going to give us a bunch of stuff, okay? So basically what we're doing is we're testing to see if the means of these two data are the same or not. So our null hypothesis is going to be basically that mu1 equals mu2. Okay? So our alternative would be, if there was more than one, this would make more sense. But since if there was more than two, this would make more sense. Since there's only two, it doesn't really make that much sense. But we'll say at least one mu is different. That would make more sense if there was three. Okay, all you have to show is that at least one of the means is different than the other ones. But since there's two, we could just say this, or they're not equal. Okay, you could say or mu1 not equal to mu2. This is mu1 and mu2. Okay. So we have our data output. So the first thing we want is our F ratio, sometimes referred to as the F statistic. That's going to be our first value here. That's going to be 1.8597 or 1.86, depending on what they want you to round to. Okay, our p-value is right below it. That's going to be 0.20978 or 0.210. Okay, so now it says, now run the independent measures t-test on the same data. All right, so that's going to require a different test. So we're going to go back to our stat menu, over to tests. We're still going to scroll up, but you'll see, so you're not going to scroll up, you're going to stay where you are. You're going to stay right here at the top. It's the two sample t-test, option 4. We have two samples here. We're running a t-test on them, so it's going to be two sample t-tests. And we're going to input data. Okay, so our list 1 was L1, our list 2 is L2. Frequencies are always going to stay 1 and 1. And then we're trying to show the alternative is that they're not equal. Okay, that's what we said here. This option pooled, don't even worry about that. Just make sure it says no. We won't get into what that actually means. And we're going to hit calculate. Okay, get a whole bunch of new information. But all we're worried about is the test statistic t, which is 1.363 or 1.36. And our p-value 0.21885 or 0.219. Okay, and the last, what do you observe about the p-values? They're both rather large. They're higher than any rational significance level. So we don't reject the null. We fail to reject the null. So then it says, what's the relationship between F ratio and T statistics? Basically, F ratio is used to show whether the variances are the same or different, and the T statistic is used to show whether the means are the same or different. Okay. The most important thing from this video is just to figure out how to find the independent measures t-test using two sets of data.